Now that we had some practice in solving equations, we're going to be looking at inequalities. We'll start with simple inequalities, and then we'll move on to something called compound inequalities. We'll start off by writing a comparison. We're going to use the inequality symbols, and we want to write two inequalities that involve -2 and 4. Well, I can start off by saying that -2 is less than 4. Then I could also write 4 is greater than -2. So again, I read it from left to right. Now I'm going to apply some of the same principles of solving equations to solve inequalities. As long as I do the same thing to both sides of the equation, it's going to keep its true value. Okay? So let's look a little further at these inequalities. We're going to do, again, the same type of operations, inverse operations that we use for equations, but there are a couple of very important differences. When we're going to isolate this variable, we can add, subtract, multiply, or divide the same number on both sides. That's what we've done before. But now comes the most important part. When you multiply or divide both sides by a negative number, you must reverse the inequality symbol. So we're going to see a couple of examples of that in just a moment, but that becomes the one very important difference between how we go about solving equations and inequalities slightly differently. So we'll start first off by remembering how to graph them. Remember, just to graph a point on a line, it's a solid circle. Here we're talking about a graph of an inequality in one variable is a series of points on a number line that corresponds to the solution. It's just not one number. So we'll start by finding that number on the number line, and this is 3. If my symbol is less than or greater than, it's going to be this open circle. And then this says that x is all real numbers less than 3. So then we're going to shade everything into negative infinity. In the second problem, I now have a greater than or equal to, so I'm going to locate 5 on my number line, and this time I'm going to put a closed circle, and I'm going to shade everything that goes in the greater direction. And all my solutions will be any values into positive infinity, including 5. In the first one, it doesn't include 3, only numbers less than. So here is what I was referring to. If we're using the less than or greater than symbol, we'll use the open circle, which means that value is not included in the solutions. If we have a less than or equal to or greater than or equal to, we're going to then have that closed circle. That means that the number at that particular point is also part of the solution. We'll start with some very simple ones. Let's solve and graph. Well, let's start by solving the way we know how to inverse operations. Let's add 4 to both sides. That gives me 3x is greater than 12, and then I'll divide by 3. My solution is x is greater than 4. I'll find 4 on my number line, open circle, and shade everything greater than, which means I can't have 4 as my solution. If I said 4 times 3 is 12, and 12 minus 4 is 8, well, 8 is not greater than 8, so it does not work. I can pick any value other than that. My second one is subtract 2 on both sides. I get 5x is greater than or equal to -5. I'll divide both sides by 5, and I get x is greater than or equal to -1. Once again, I see that I have a greater than or equal to sign, which means it's going to be a closed circle at -1 and shading everything in the greater than direction. That means that I can choose -1 as a solution because -1 times 5 is -5, and -5 is greater than. Because this little line is here, it says it includes that number. Now, I do want to do one where I show you, without the graphing, that reference to the negatives. If I have -4x is less than or equal to 12, I'm going to be dividing both sides by a negative. And that rule says if you're dividing by a negative, you reverse the direction of your inequality. The same is true if you're dividing or multiplying. So I'm going to leave you with that problem. We'll do many more in class. You'll do a little practice of graphing for your assignment tonight, and we'll go over this in class in more detail. See you then.